Hey guys, this is Mitch with FindPoint CGI, and today we're going to go through the process of creating a day-night cycle inside of Godot. So this is an extension of our Animal Crossing like timing system tutorial that I did, I want to say like a week or so ago. And basically we're just going to go ahead and make it so that the directional light rotates and changes color depending on the time of day. We're also going to make it so that the environment also changes, and we are going to go ahead and hook it up to our timing system so that way we can actually go ahead and have a proper day-night cycle. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing we need to do is we need to set up our lighting system. So what we're going to do is we're going to come into our spatial node here. We're going to right click our spatial node, add a child node. We're going to add in an environment node here. So that's going to be our world environment. And then we're going to come over here to our empty, and we are going to click on that and go ahead and add in our new environment. And then we're going to click on our new environment. We're going to go down to our background. We're going to click on our mode, and we're going to change it to a sky. And this is going to give us some lighting. And you'll notice that it's all black. And the reason why is because we haven't set our sky mode here. So we're going to go ahead and click on that and add in a procedural sky. And you'll notice now we have a bunch of much nicer lighting than probably what we would have had if we didn't have a procedural sky, right? So what we can do now that we have this is we can go ahead and right click our world environment, add in a child node, and add in a directional light. So type in directional light, just like that. And we're going to keep it at its default spot, which is on the Z-axis. If we want to move it around, we could, but I think the Z-axis is fine. If you want to make it X-axis, you could just rotate it, and then the code should work regardless. Now, from here, we need to go ahead and set up our code to make our environment change, if that makes sense. So what we're going to do is we're going to right click on our world environment. We're going to go ahead and attach a script, and I'm going to call it day night, and we'll go ahead and call it that for now. So the first thing that I'm going to do is I'm going to go ahead and add in a slider here so I can control what the date time is, so we can actually kind of finagle with this, right? So I'm going to right click my control node. I'm going to go ahead and add in a slider and add in a little horizontal slider here. We'll just pull this out and put it somewhere like right here. And that'll just give me some control so I can mess around with this, right? So go ahead and click on our node, and we'll go ahead and say, hey, on value changed. Let's select our world node and connect it. So that way we can call out and change our code, if that makes sense. So what I'm going to do is I'm going to now rotate my directional light based off of what my slider is set to. So we'll go ahead and say $ directional light dot rotation degrees is equal to, and this uses a vector 3, so we'll say vector 3. And let's set it to value, comma, 0, 0. So now if I save this and I run this, and I move this, you'll notice that it does slightly change. See that? So that's cool. That's good. But if we come in here and we print this, and we refresh and we start running this through, you'll notice that we're going from 1 to 100. But that doesn't quite work for a rotational object, right? You need to be 1 through 360, right? So how do you do that? Well, the easiest way is to make this go from 0 to 100, right? And then multiply it by 360. So if we take our value, we multiply it by 0.01, which will go ahead and take that number and reduce it down to a decimal. So it'll be 0.41 instead of 41. And then we'll multiply it by 360 degrees, because that's the degrees that we're trying to rotate this thing by. If we save that and then we replay, and we move this around, you'll notice that now we can control all of the different directions that this object is rotating in. Perfect. That's exactly what we wanted. Now, something that I'm going to add here is I'm going to add in a plane here. So I'm just going to add in a little mesh instance, and we're going to go ahead and make that into a plane mesh. And I'm just going to scale this up to be something large. So that way we have something that, you know, the object can sit on top of. So that way we can actually see when our time has changed. Because beforehand, it got kind of hard to see. But if we have an object that we can kind of use, we can get a better idea of how it looks. Now, also, something that I'm going to want to do is I'm going to want to make it so my directional light actually casts a shadow. So let's enable that. And let's see if that makes it a little bit easier to see. So if I kind of adjust this, and there we go. Now, that seems like that would work out pretty well for us. It's a little on the funky side, but I think it'll work for what we're trying to do. Okay, so from here, we need to go ahead and set up our system to handle a day-night style cycle, right? And what we can do is we can come into our world environment. We can come down to our little H slider change, right? And we can say, okay, first, let's set our directional light energy. Okay, and we're going to set that equal to 1, which is just defaulting it to 1. That way, if we want to change it later, we can. We have that ability to. Now, from here, we can go ahead and say, okay, we need to have this thing work on a day-night cycle, right? So what we can do is we can say, okay, when you're about halfway through the slider, I want you to be in daytime. And if when you're on the other half of the slider, I want you to be at nighttime. So what we're going to do is we'll say, hey, if value is greater than 50, then we're going to go ahead and say, all right, let's rotate our thing like normal, okay? And if it's not, if value, we'll say else if value is less than 50, then we're going to assume that we're in our night cycle. So let's just take this bit of code here. We'll go ahead and duplicate it. And instead, we will rotate this multiplied by -1 and then make this 180. And what that's going to do is that's going to give us a lot of flexibility here. So if I get rid of this little bit of code up here, if I get rid of this little bit of code up here, and then we go ahead and hit play. So you'll see that when I rotate this, you'll see it's daytime. Now it's daytime again, right? Well, that's kind of weird, right? Why would we want to do that? Well, one time, so this is our nighttime, right? So this would be where our moon would be. And then this is our daytime where our sun would be, right? And you could do it many different ways, but this is the way that I like to do it. And what we'll do is we'll change our light energy to something small like 0.2. So now when I hit play and I move my thing up, you'll see it's kind of dark-ish. And then when I pull it back up, you'll notice that it's way brighter the second time through, right? And that's because it's now nighttime, or it's now daytime. So this is our daytime, and this would be our nighttime slider, if that makes sense. Now, I am going to adjust my camera because this is making it very hard to tell what's going on. So I'll pull this camera just around to the other side here. So let me just pull this over here and let me rotate it something like that. And if I hit play, that'll probably make it a little easier to see what's going on. So if I bring this up, you can see that it's darker and then it's lighter. Perfect. That's exactly what we wanted. But now we need to go ahead and we need to set our skylight color to actually match. We don't want it to necessarily be a bright white light or something crazy like that, right? So what we can do is we can go ahead and go into our script here, and we'll come up here and we'll go ahead and add in some colors. So we'll say colors is equal to, and we're going to make that an array, and we'll go ahead and say color 8, and we'll pass in some values. So in my case, I picked these values on purpose, and you guys can pick whatever values you'd like, but in my case, I'm going to go 247, 103, 7, and then we'll put a comma in here, and then we'll go ahead and say, all right, color 8, and we will do 52, 58, 64, and then our last color that we're going to do is pure white. So 255, 255, 255, and that should about do it for our colors. Now, if we breakpoint up here, oops, I forgot my var colors. Now, if I put a breakpoint right here and I hit play, you'll see it will, as soon as I adjust this, it'll snap right here and give me a breakpoint. Now, if I come down here, I can click on my array of colors, and you will see that I have a orange color, a black color, and a white color. And each one will be useful for its own thing. So first, let's do the black and white color, because that'll be the easiest one. So what we'll do is we will come down to our value of over 50, and we'll go ahead and say, all right, it's now dark, so let's set our color to the correct color. So $, directional light dot light color is equal to colors, and we will set that to our first element. It looks like it's our first element. So go ahead and set that to our first little element here. Not I guess technically our second element, but it'll element 1. And that will set our color for this. So now, if we come up here, we can do the same thing, but for our light color. So we'll come up here, Control C, Control V, and we'll go ahead and set this to number 2. So now if we refresh this, you'll see that it is going to break point because I forgot to uncheck my thing. So you see that when we start scrolling through here, you'll see that once we get over here, the color turns bright white. Over here, the color is a nice dark color. Now, the easiest way to tell the difference is if I get rid of my procedural sky, you can see it's a dark color and it's a white color. Simple enough, right? So the procedural sky can cause problems sometimes. So you gotta keep it in line by getting rid of it sometimes. So we'll go ahead and re-add the procedural sky in. Now, our next thing that we can do is we can go ahead and make our sunset operate, right? You saw how we had a bright white light down here once you got to the bottom, but that's not how actual lights work, right? You have a sunset and a sunrise that's orange, and that's where this other color comes in. That's where our first color index comes in, right? Because that's our orange color. So how can we do it? Well, what we can do is we can set a value threshold to when it starts going into sunset. So we can say something like, I don't know, 90 or maybe 95, right? Because that's pretty far along the bar. So we'll say if value is greater than 90, then let's go ahead and set our color, right? So we'll just go ahead and set our color here, and we will set it to our 0 color. Now, I don't like where this is because it should probably happen before we decide our color. So we'll do that. And we don't really want to set it to color 2 if value is greater than 90. We don't really want to reset our color. So we'll go ahead and say else set our color to this color, right? So now if we hit play and we run this through and we go past 90, it should have fired off, but it didn't. So if value is greater than 90, let's go ahead and place a breakpoint there. And let's see what our value is right now. Value is 99, so it's greater than 90. Let's see, value is 100, greater than 90. So yeah, that should, well, you can see it is changing color, kind of, but it doesn't seem like it's changing very well. I think the reason why is it's our world environment is colorizing it. If I undo it, yeah, there we go. So you can see, bam, look at that. It changes straight away to the correct color. But this isn't how sunrises operate. Or sunsets in this case. This isn't how sunsets operate, right? They don't just immediately flick over to orange, right? They kind of gradually move to orange, right? So how can we go about making this better? Okay. Well, what we can do is we can go ahead and do a little bit of lerping, some linear interpolation work, right? To make it look nice. So what we can do is we can say, okay, I know that I want to set my value to this color, but I don't want to set it the whole way to that color. So what we can do is we can go dot linear interpolate, and we can set a color for it to be, right, to start from, and then set a color that it needs to mix with, right? So we're interpolating to a color, not from a color, right? So we can actually bring our color 0, set this to our color 2, and then we can pass in how we're interpolating our value. So we'll go ahead and say value minus 90 divided by 10. Okay. And I know you're going, all right, how does this math work? Well, what I'm doing is I'm taking the difference between this and my value, and I'm dividing it by 10 so I can get a 0 to 1 threshold. Now, this is a number that we're going to have to keep track of. So if I set this to 95, then I would need to make this 5 because I need it to go from 0 to 1. I need to have it as a percentage value, if that makes sense. So if I hit play, and you'll notice everything's black because I got rid of my world environment to show you guys this. So if I bring this over here, you'll see bright white. And then as I slowly move in there, you'll notice that it is getting more and more orange. See that? So now it feels better, right? It feels more like a sunset, right? So now we got to do the same thing for sunrise, right? We have to do the exact same thing, but the opposite. So what we can do is we can come over here and say, okay, well, we know 50 is our middle point between night and day. So that means that 60, since this is 90, if we just move it forward by 10, right, then we can just go ahead and do the same exact thing. So if we just basically copy this code, paste it, and then make this 60 and make it, if this value is larger than 60, then we want to lerp to our other color, right? So we can go ahead and say, okay, I need to lerp from 0 to 2. Simple enough, right? And then I can just go ahead and minus the value of 60 and then divide it by our 10, right? But this wouldn't work 100%, and I'll show you why. So if we come in here and we do this, you'll see it's red, and then it immediately snips over to white. But why is that, right? Well, the reason why is because this value here, when you do that minus 60 divided by 10, you are getting back your 10, but you're going in the opposite direction than you would expect. So you need to multiply this by minus 1. Okay, and what that's doing is it's basically flipping your value, because what we're getting back when we do this, and I'll print it out for you and show you what you get back here. So if I print this value here and I skadoodle this across, you'll see that I'm getting negative numbers. But I can't have negative numbers because that's not how sunrises and sunset operate, right? You don't have negative numbers, right? So instead, we need to multiply it by minus 1 to kind of fix that negative number issue. Oh, I forgot. That's why. Else if. Yep, I knew there was a bug here. Okay. 0 and 2. And let's see if that fixes it. So we'll bring this up. Goes from orange to white, back down to orange, and then to dark. Perfect. So you can see our nighttime cycle and our daytime cycle. Awesome. Now that we have this, let's go ahead and figure out our sky, right? Because we don't want our sky just to be this procedural sky that we have that's just top color and horizon color, right? Because if you look at it, like, wow, this looks really nice. Like during the day, you can kind of go like this and look at that. It looks beautiful, right? But when you start moving over into this area where it starts colorizing to orange, you'll notice that it's still blue. And the reason why is the global illumination is overriding our scene, right? So what we can do is we can actually go ahead and override this color and the horizon color to make it be the proper color that we're looking for. So what I'm going to do is I'm going to go ahead and come up here and I'm going to say var sky underscore colors is equal to, and we'll go ahead and set this to a couple of colors. Now I'm just basically going to copy these guys for a second and paste them, and then we're going to make some adjustments. So we're going to say something like 219, 154 or 152 and 108. And then I'm going to set this one to the same one that it is, because that's fine. And then we need a bright sun-like color or sky-like color. So I'm going to set it to this color right here, which is 165, 214, and 241. So 165, 214, and 241. And that'll just give us a nice sky color. Okay. And I know I'm kind of running through this pretty quick. But if you guys have any questions, throw them down in the comments. I'm more than happy to help you guys out. But if we come down here, what we can do is we can go ahead and set our sky color and our horizon color. Okay. And what I'm going to do is I am going to go ahead and basically copy paste this linear interpolation colors. So that way we can actually just make it work. Okay. So what we'll do is we'll go ahead and copy this little bit of math here. I'm going to go ahead and hit enter. I'm going to tab this in and I'm going to go ahead and set my environment colors. So I'm going to say environment dot background sky dot, and you're not going to get any syntax covering for this. So just trust me on this one. Sky underscore top underscore color is equal to, and we'll go ahead and paste this in, and I'm going to change this to sky colors 2 and sky colors 0. And basically we have the exact same thing that we're going to do. So I'm going to duplicate this and we're going to say environment.background.sky.color, and we will paste this in. And then we will go ahead and basically just keep the same thing, but just sky colors, right? Because we kept everything pretty much the same. If I remember correctly, if I scroll up, I mean, it's basically the same, right? Which means also that if we copy this and we come down here and we paste, we can go ahead and set our environment color to sky color 1, I believe. And then we can go ahead and set this. Awesome. So now if we hit play, awesome. So you can see that it now changes your environment color to kind of match your environment. So that way you get that nice global illumination. Now, obviously you don't want to change this all the time because it has to redraw everything. So it's really hard on your system to do that. But it does work, and you probably only want to draw it every once in a while. So you may want to make like an adjustment somewhere so that way it doesn't run constantly, right? So what we can do from here is we can go ahead and set our horizon color as well, because you don't really see it. But if I rotate my camera up so we can see the sky, you'll notice that if I pull this here, you'll see it's nice and dark, but our horizon is really bright, which is kind of weird, right? That's not how horizons are in real life, right? They're a specific color that's based off of what our previous color was, right? So let's set that up. So let's go into our world environment and let's go ahead and basically duplicate this and change this from sky top color to sky horizon color. And the easiest way to find what this stuff is, by the way, is just to come over here and hover. And you can see property sky top color and property sky horizon color. And that's pretty much how I pulled these values here, because syntax highlighting doesn't work for some reason when you pick something like this. So what I can do is I can just go ahead and copy this and paste it up here. Oh, it does not like me, so I'll just go ahead and copy this, paste it, and then do horizon color. And what we'll do is we'll come over here, and we need to now linearly interpolate between two colors. Again, right, like we've been doing. And what we can do is we need to interpolate between our current color and our... So what this will be is this will be 2. And then we'll go ahead and duplicate this, and we'll go ahead and call this horizon as well. And we will go ahead and say linearly interpolate. And we're going from 2, and actually this would need to be 1. This would need to probably be 1, and I think that'll do it. Sorry, I can't quite remember my colors very well, so hold on. Let's pull this so it's dark. That's fine. That's correct because that's the dark color. And then it goes to light, which is fine. Then it goes to dark, which is fine. Awesome. Now, these operations are really rough on your system, I'm not going to lie. So you may want to just use some kind of sphere or something like that that you can use to kind of associate with date time. But now that we have this, let's go ahead and make it so that all of this is set by our date time, right? We have this event where it fires off our stuff. So we're going to go ahead and connect it to our signal. So let's go ahead and come up here and say get tree.get nodes in group. And let's go ahead and get in our time manager. And I'm pretty sure that's this node here, correct? Yes, it is. So we'll go ahead and do that. So we'll come in here and say get nodes in group time manager. And I'm pretty sure that's the group that this is a part of. If I select my node, select my group. Yep, that's correct. And then we will go ahead and say dot connect, and that's not going to work because this is an array. So we'll hit array 0 and we will connect. If I remember correctly, our time manager has time min has changed. So let's copy that, come over here, comma, self, comma, on underscore time min has changed. We'll go ahead and copy that, come down here and say func time min has changed. We'll take in our time and then we will go ahead and do a little bit of finagling here. And the reason why I'm saying we'll go ahead and do a little finagling is because we need to make our stuff from a 0 to 1 slider. And what I mean by that is if I go ahead and just print our time and I go ahead and I come into our spatial node and on startup, I say, hey, ready, go ahead and do a thing. And then emit signal time min has changed, comma, time. That way, as soon as the game starts, it'll just emit a time for me, right? And actually, I think it'll just be old time. My apologies. So we'll pass that in. If I come over to my world node and I go ahead and I put a breakpoint here and I run this, you'll notice that our time is an object. So we need to convert that object into a 0 to 1 scale for our linear interpolation to work, right? So what we can do is we need to set our time to be in that linear interpolated scale. So what we can do is we can go ahead and say, okay, var h is equal to wrap f float t dot hour. And what that's going to do is it's going to wrap our hour time into a float, right? And then we're going to go ahead and add this plus float time dot minute. We're going to divide that by 60. So we can take our float time and make it into our hour time and kind of normalize that. And then we need to go ahead and tell our wrapf the rest of the parameters that wrapf expects. So if we hit comma, wrapf actually expects us to have a lower threshold and a high threshold. So we'll say 0, 24, and that'll wrap it between 0 and 24. And it's going to get mad at us, I think. Let me see. There we go. And what this is going to do is it's going to wrap this float. So it's going to add our time hour plus our time minutes divided by 60. So that way it pulls back a proper float time for us, if that makes sense. Now, this might be a bad order of operations if we look at it. So I'm going to wrap this like this. So that way I can guarantee that this happens first. Now, if I hit a breakpoint here and I hit play, I'll show you what this did. So if we look at H is 21.1666667. So it took our hour, which is, if I remember correctly, 21. It's 9 o'clock here. And minute, which is, according to this, 1.6666 of an hour. because we divided it by 60. So if we look at our time variable, you can see that we're 10 minutes into our time. And the only way to take something and make it from a 0 to 1 scale, right, a percentage scale, is to divide it by the number that you're looking for. And since there's 60 seconds in a minute, or 60 minutes in an hour, it correlates to a percentage number. So according to this, we are 16% done with our hour. And I know that that's kind of confusing, but it's just, it's math. And math is awful. But now what we need to do is we need to go ahead and make it within a 24-hour scale, right? We need to make it a percentage of our 24-hour total scale, okay? So much like what we did here, we need to take this number, divide it by 24. So we can go ahead and come here and say, okay, var time in day is equal to h divided by 24, okay? And we'll go ahead and throw a breakpoint here. And we'll go ahead and let this run through. And you'll notice that it says we're 88% done with our day, right? We are now 88% completed with the entire day of 24 hours, okay? And what we can do is we can now multiply this by 100, and that's going to put us into a value of 0 to 100, right? So that way these values all work and our slider still works, because we could technically pass this in and then get rid of this, and that would basically handle this 100% fine. But I wanted to do this operator here so that way I could use my slider with this, if that makes sense. So we'll go ahead and refresh, and we'll let this run through, and you'll notice that, well, not much has changed. And the reason why is we did not call our function, so we'll say underscore on h slider changed, and we'll pass in our time in day like that. And we'll go ahead and allow that to run. And you'll see that not much has changed again. So let's go ahead and take a look at this. Let's see what it's doing. So I think I know what's going on. It's setting it to daytime. And it's setting our slider. So if we come in here and we set our slider here, so that way we can just see what our slider value is. Let me go ahead and do that real quick. So let me come in here, attach it to a group, and go ahead and say H slider. And I'm going to copy that. And I'm going to come over here and I'm going to just say, okay, get tree dot get nodes in group. And I'm going to pass in my H slider. I think I know what's going on, but I just want to show you guys. Dot value is equal to time in day. And that's going to go ahead and set our slider value. And it's mad at us because every time I forget that this is an array, so I'll pass back our first value. And if we run this, you'll see where we are. But if we move this, you'll see that everything is correct. It's correct, but you'll notice that everything's kind of offsetted wrong, right? And the reason why is because right now it should be nighttime, right? But everything's kind of offsetted a little bit incorrect. So we need to add an offset to this. So I'm going to come up here and I'm going to go ahead and say var offset is equal to, and I'm going to default it to 20, which is a number that works for me. Now you guys can set it to whatever you'd like, but that's the number that has worked for me in the past. So I'm going to use that number. We'll go ahead and come up here and we'll go ahead and add in a 20 offset. So we'll say offset like that. We'll go ahead and run this. And you'll notice that that worked, right? It's kind of in a weird position, but it seems to have worked, right? Kind of, right? Because if we run through this again and we hover over our time and day, we are actually over 100. But we don't want to be over 100. So let's go ahead and say, hey, if time in day is greater than 100, then we need to go ahead and do time in day minus equals 100, and that will go ahead and fix that, right? So now, if we run this, you will see that we are now at nighttime. Awesome, and that's exactly where we want it to be. Now I can come in here and fiddle with my colors and my things like that to make it look nice, but I mean, that's pretty much everything, right? If I pull this up, you'll see that that's about where I would expect it to be at this time of night, right? And it's a little hard to see. So if we just kind of come up here and we change this color here, if I actually click on my world environment, click on my inspector, and I just kind of set this to a higher color. So let's just say like, 171, we'll say. Let's go ahead and do that. There we go. It's a little bit brighter, a little easier to see, but you can see that that's about what I would expect for 9 o'clock, right? That's about correct. So that's perfect. That's exactly what we wanted. The last thing that we need to look at is getting our sun angle to match with what our sun is actually at. So if we go to our world environment and we go to 3D here and we uncheck our preview, you can see we have our little sun here. And we actually have a little rotation thing right here. We can change our latitude and longitude. So we can actually pull this up and pull this down to kind of make it look like the sun is somewhere in the sky. But we don't want to have it not match up with what our directional light is, right? So what we can do is we can go ahead and hit on our script and we'll go ahead and come to our on HS slider changed right here. And we'll go ahead and make this match up. So we'll go ahead and type environment dot background underscore sky dot, and in our case, I believe it's called sun latitude. So we'll go ahead and put that. So sun underscore latitude is equal to, and then we need to set it to a value. And much like what we've been doing throughout this entire tutorial, we need to make it so that it is from a 0 to 1 scale of what our value is. What we can do is we can go ahead and say, okay, value times 0.01, much like we're doing up here, and then multiply it by 180, right? Because we only want to go from 0 to 180. Because if we look at our world environment here and we set this to 180, you'll notice that it's all the way down here. And if we set this to 0, you'll notice that it's all the way down here, which is perfect. And if we go past that, you'll see that the sun is no longer existing, right? It doesn't exist in the sky or anywhere else. And that's because the sun is actually below the earth at this point. So you're not going to see it. So we don't need to worry about values past 180, right? So what we can do is we can go back to our script and we can go ahead and save this and see what happens. Now it's going to be really hard to see, especially since we can't really see our sun because we can't move our camera. So let's go ahead and add in a new asset. So let's go to the asset lib, and you can see I already searched for camera, but basically search for camera. And then come down here and there should be a simple free look camera here. And we'll go ahead and download this camera and attach it to our camera. So we'll go ahead and install it. We'll grab our camera, drag it up onto our camera. And now when we hit play, we have our Godot controls inside of our camera. We can actually move around and do things like that. So we can see where our camera is. And if we move our slider, you'll notice that our light also moves. If I go all the way down, that's about right? That sounds about right. But if I go all the way to about halfway, you'll notice that the sun is about halfway, which is not about correct, right? Because we're not going halfway through the slider. We need to divide this by 2, right? So that way it'll match properly. So what we can do is we can either divide this value by 2 and go divided by 2, and that might work. Or we might need to minus our 50 from it, so that way it goes from a 0 to 1 scale. Let's see if that actually works. It does not. You can see how it's not quite correct. So let's go ahead and do the other method. Let's say minus 50 multiplied by 2. And the reason why we're multiplying it by 2 is because when you take your value and you divide it, or you minus 50, you're taking it from what would be 50 and up, right? You're taking off 50. And then you need to multiply it by 2 to make it into a 100 range. So let's go ahead and check that out. So we'll pull this off to this side, and you'll see that we have our sun. And then if we pull this to the other side, you'll see that we have our sun. So that's about right. That's what we wanted. So now the last thing that we have to do is we have to do our moon, right? So let's go ahead and basically just copy this, come down here, paste it, and instead let's set our value just to value instead of -50. Multiply it by 2.1 and 180, and that should about do it. So let's take a look. Let's go to our beginning. So you can see there's our moon. We'll drag this up. It's about there. That's about right. We'll bring this over here. That's about right. And that's about right. Now, in our case, we may want to make some more adjustments to how our sun versus our moon looks. And that's up to us in terms of how we want to design it. So you could actually come in here and be like, oh, well, you know, it's the moon, right? So I want the moon to have a special angle min or an angle max or a special curve. And actually, if I kill this and I go back to my 3D and I look for my sun, I can adjust my angle and that'll make it so it's tighter like this. So I could make it more tighter maybe for, you know, for the moon versus the sun. Maybe the sun isn't, or maybe the moon isn't as bright. We can kind of adjust our curve to kind of make it a tighter reflection or tighter bloom value or something like that. But in general, this is how we can go about making it different. And if we wanted to, we could also adjust like our energy value. Maybe our moon is bigger than our sun for whatever reason. We could do that as well. Now, the final thing, we're going to do a little bit of refactoring here. And the reason why is just because I don't really like how this is working out in the sense that our directional light, we don't want to go and fetch this every single time. That's really bad for performance. And we also should probably see if there's any math that we can do once instead of doing multiple times. So you can see how like all of this is the same math. So we could probably cheat that a bit and make that a little nicer. So let's do that. So the first thing I'm going to do is I am going to go ahead and take this out and make a function here. Call it set time of day. And we'll go ahead and I'm coding in C#. So hold on, there we go. And then we will pass in a value here. And I'm going to just basically call that from here. So I'm going to say set time of day value, and I'm going to do the same thing right here where I am going to do this. There we are. And that just helps us with making this a little bit more nicer looking instead of just allowing us to dump all of our code into a on H slider value change. It just doesn't make sense. So we'll just do that little bit of refactoring there. And then we're going to come down here and we're going to do a little bit of refactoring here to make this a bit more efficient. So the first one is take our directional light. Let's go up here to our ready and let's add in a var light. And then let's go ahead and go to our ready and say light is equal to directional light. And we will go ahead and say $directional light so it can pull that back. And then I'm going to go ahead and grab this. I'm going to copy it and I'm going to paste this in here as a object. That way I don't have to go and fetch this object reference every single time. So that should be a bit faster than what we're doing now. There we go. And now what I'm going to do is I'm going to do a little bit of math to just kind of make this a little easier on us. So we'll come down here. We will find where we're doing our math, this math right here. And we'll just call this var light value, and we will pass in this little bit of code here. And then we will go ahead and replace this with that, and that should do it. So if I get rid of that, and then I get rid of that, and we're going to need to pass this into here like that. There we go. And we'll go ahead and just basically replace our value here with that. And that'll just allow us to do that operator once instead of multiple times. And I'm just basically going to copy this And actually, I already have the code right here, so we can just get rid of this print statement here. So we'll go ahead and paste and get rid of that. And then we will take our light value var, and we will go ahead and paste it here, but it looks like I'm missing a multiplies by -1. So we'll go ahead and do that. And then I'll go ahead and paste it in here, and paste and paste. There we go. And that just makes it a little bit more efficient. We don't have to do that math every single time. Granted, it's not super slow, but we just want to make sure that it's efficient, right? So I think that will about do it on our end in that sense. So let's see, that should work. If we hit play, let's verify that this works. Then we can get skedaddling. Yeah, and you can see it's a bit more efficient. It's a little bit nicer. So that's good. So that is all I have for you guys today. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button, because I am here to make content for you guys. Now, this video was a viewer suggestion, so if you have any suggestions, please throw them in the comments below, and I'll be more than happy to put them on my Trello board. Link is in the description, and get to them as soon as I can. And hey, if you guys have any questions or comments about this video, please throw them in the comments below, and I'll be more than happy to answer any questions or respond to any comments that you guys have about this video. But that is all I have for you guys today, so thank you so much again for watching, and I will see you all next time. Thanks.